So let us take unit vector n common. So epsilon naught E plus P, sorry, this goes this side, this becomes positive, plus P into unit vector n is equal to sigma. So quantity epsilon naught E plus P is called dielectric or electric displacement. Sometimes it is called dielectric displacement, electric displacement, and it is denoted by D. Okay, so this thing is called electric displacement. Why? Because electric field is displaced. Electric field is displaced by multiplying by epsilon naught, and it is displaced by P. Now this is also presented by symbol D. So D is simply epsilon naught E plus P, or D dot n. From this equation, D dot n is equal to simply sigma. So instead of electric field, there is a new symbol or new quantity which is electric displacement. This, and this D dot n cap is equal to sigma. The significance of D is this. What is the significance of this D? In vacuum, E is related to free charge density. In vacuum, E is related to free charge density. But when a dielectric medium is present, that means if we fill some dielectric between the capacitor, the corresponding role is taken by D. So there is a field, but this field is when we are in a free space or vacuum. But when a dielectric is filled between the plates of a capacitor, the role of E is taken by D, this electric displacement, sometimes called dielectric displacement. Now the ratio of D and E. So D is simply sigma epsilon naught upon sigma minus sigma P. How did we calculate this? Because D is now only sigma and E was sigma minus sigma P upon epsilon naught. So this D is epsilon naught K. Again, if you see, this is epsilon. If you see, this is epsilon. So the ratio of D and E is epsilon naught K. This is which was epsilon. So the D is related to this material quantity dielectric constant. Now D is equal to epsilon naught Ke, and this P is equal to, from this equation, P is equal to D minus epsilon naught E. P is equal to D minus epsilon naught E. Let us put this value of D. So epsilon naught is common, K minus 1, K minus 1 E. K minus 1 E, and so now what is this? P is equal to epsilon naught K minus 1 E. So if you remember, for a linear dielectric, we have seen that this polarization is equal to electric field, and there was a constant which we had called electric susceptibility. So from this equation, if we take that thing, P is proportional to E, and this epsilon naught K minus 1 is this electric susceptibility. So electric susceptibility is epsilon naught K minus 1. This is the electric susceptibility. Now let us see this example 2.8. A slab of material of dielectric constant K has the same area as plates of a parallel plate capacitor, but has a thickness 3 by 4 D, where D is the separation of plates. How is the capacitance change when the slab is inserted between the plates? So we have a capacitor. The area of its plates is A, and distance between them is d. Okay, the distance between these plates is d. Now we have a slab, it area of its surface is also a same, but its thickness is not d, it is less than d. It is a solid block and it is an insulator or dielectric. Its thickness or its width is 3 by 4 of d. That means if we insert this material here, it will not fully cover the whole gap. So there is a gap. So what will happen in this case? Previously we have seen what will happen when this dielectric is completely filled in between. But if we partially fill the dielectric, then what will happen? This is this numerical. Now let's start. E naught is equal to V by D. We know that this V naught is equal to E naught into D. We are talking about vacuum. So E naught is equal to simply V naught by D in case of vacuum. Be the electric field between the plates when there is no dielectric. In case of no dielectric, we are representing it by same E naught when there is no dielectric. So this is the electric field, and the potential difference is V naught. Again I am saying, when there is no dielectric, we always represent by with symbol E naught, V naught or C naught. So this means there is no dielectric. If the dielectric is now inserted, the electric field in the dielectric will be, again see, they are saying in the dielectric, the electric field in the dielectric will be E is equal to E naught by K. Because how we did calculate? Because voltage in the dielectric is V naught by K, and for dielectric this distance will be 3 by 4. So V into 3D by 4 is equal to V naught into 3D by 4. This is upon K. Okay. So this 3D by 4 cancel, because electric field will not change the width of the dielectric material. So again the same ratio will be for electric field. Same ratio will be there for the electric field. So electric field will be epsilon E naught by K. So electric field will also be reduced by K. So electric field reduces, voltage reduces, capacitance increases. The potential difference then will be, in that case, what will be the potential difference? Let us see. What will be the potential difference? Potential difference V is equal to epsilon naught D. So this is total potential difference. This is total potential difference. For how? See, this was the case. So this was the dielectric placed and it is not taking the full space. So it is taking 3 by 4D and 1 by 4D. 1 by 4D is still in the vacuum. 1 by 4D is still in the vacuum. 3 by 4D is filled by this dielectric material. So the total potential 1 by 4D is because of this non-filled part, 1 by 4 part, this is 1 by 4D, and 3 by 4 part is because of this dielectric which has a reduced electric field E naught by K. So the total potential is now this. Total potential has changed. How it is changed? It has two components, this dielectric component which has been reduced and this E naught into 1 by 4D, this part, because of this which has same electric field. When you add this E naught D is taken common, 1 by 4 plus 3 upon 4K, and if you see this E naught D is V naught, and you solve this, so you get K plus 3 upon 4K. Thus the potential difference decreases by, potential always decreases, that you know when we insert dielectric. So potential difference will decrease by the factor k plus 3 upon k while the free charges q naught on the plates remain unchanged. So free charges q naught on the plates will remain unchanged, but this potential difference will be decreased. Now let us see the capacitance. Even though voltage or potential has been decreased, but the capacitance will increase. The new capacitance is equal to q by v, because charges will remain same, free charges will remain same, the charge on these plates will remain same, only charge density will be affected but charges will remain same. So the new v is k plus 3 upon 4k. This is q by v naught, which was previously c naught. So the capacitance has increased by 4k upon k plus 3, while voltage has decreased by k plus 3 upon 4k.